Johan Janssen. I don't work for Lego, in case you're wondering. I work for a company called InfoSport from the Netherlands. However, my boss paid for my Lego, so that wasn't bad either. So no Lego was harmed. Unfortunately, some Raspberry Pis were harmed beyond repair. However, there are more than enough of them, so that's not really a problem. But more about that later. So this is basically the content for the next 40 minutes. If you have any questions, you can also interrupt me and ask them directly, then I'll try to answer them directly. If you have any questions, we also have a microphone available if you want to ask them loud and clear. So first, why? Why should we build Lego, and why did my company even pay for it and even paid for some of the hours that we invested in building this? There were a couple of reasons for that. The most important one, of course, was to have fun. Another reason was that we wanted to find out if we could use the same software that we are currently building with Java or Scala or other JVM languages for big companies on servers, if we could use the same libraries and languages on IoT hardware such as the Raspberry Pi. Because traditionally, IoT hardware, the software is mainly written in Python or C or some other lower level languages. But we are more familiar with Java and those kind of languages. So if we could use those languages on IoT hardware, we could develop quicker and start up quicker, because yeah, IoT is quite a hype nowadays, of course. And so we wanted to investigate that. And of course, it's also incredibly fun for kids, and it also makes it easier to explain certain things. I mean, if you have just software or just theories, such as if you have an event-driven architecture, and I try to explain to my wife what an event-driven architecture is, and I tell her that it's sending message X from system A to system B, then probably she would have stopped listening at event-driven. And that's not her fault, that's our fault. We speak some alien dialect, and if you don't have the same background, you can't understand it. But if I tell to my wife that I'm sending a message to the Raspberry Pi on my Lego train, and that message tells the Raspberry Pi which song to play, then it's perfectly clear to everyone. And in fact, I'm almost telling the same thing. So it also helps to explain certain topics. If you start with this, be careful. Before you know, your living room will end up like this. And I think it was 3 times more horrible than this at the peak, but lots of fun, of course. So what if you want to get started yourself? It's actually quite simple. You need a few ingredients. In total, it's about 50 bucks. You need a Raspberry Pi. Who of you already have a Raspberry Pi? Please raise your hand. Okay, keep your hand in the air if it's collecting dust on a shelf. Okay, so you already have one. That saves you like 25 bucks, 30 bucks. If you already have a Raspberry Pi, you need a Wi-Fi dongle, a USB Wi-Fi dongle, or a Raspberry Pi with integrated Wi-Fi. That's also possible. A battery pack. I use this battery pack because it's relatively small and can run my train for 6 or 7 hours. And I need an infrared transmitter. And why that is, we will see in a minute. And so original Lego has these controls. I can show them with Wally, for instance. So this is an infrared transmitter. The remote control for Lego. Oh. They have battery boxes in a few different sizes, and they have some different engines, such as these engines. So the train has a special train engine, but this is like a normal engine. Oh, and I forgot the most important part, and this is the infrared receiver. So basically, this one sends commands to this one through infrared. So if I drive it around, hopefully it doesn't fall off. Hopefully it works, yeah. This is normal Lego controls, basically. But if you do that with a train, and back then I lived in an apartment, and I drove the train from the living room to the kitchen, and it crashed full on into the kitchen because I couldn't control it anymore. The infrared reach is quite limited. And you can only control about 8 trains with 1 remote, so that's quite limited. So what did I do to solve that? I used a Raspberry Pi board with a USB Wi-Fi dongle in it and an infrared transmitter. So basically this replaces my remote control. And now, as long as I have Wi-Fi reach, I can control my train. Yeah, so it looks like this. A Raspberry Pi, not the USB, the infrared transmitter, and here is the infrared receiver at the back, and with that I can control the speed. This one is a bit more expensive than €50. This also has a full HD Raspberry Pi camera, so that I have live images of the train. Especially useful if I'm at work and I'm working with the train, of course only during lunch breaks, then I can see what happens, if it derails or anything, exactly. I've got a speaker for necessary train sounds, and it's also really useful to scare your kids or burglars. RFID reader, so this, it's an RFID reader. If you're from the Netherlands, it's quite similar to the OV chip card. You have a card and you have a reader, and they can simply see which one it is. So every card has a unique number, and with the reader, I detect the number and map it to a position on the track. And it works like this. So typical Dutch stuff like a cow, a car, and so this card, I map the unique number of it to the cow, so I know I'm at the cow. Camera, actually I thought this was really simple. I mean, you attach the special Raspberry Pi camera to your Raspberry Pi and you're good to go. However, that seemed a bit more difficult than I thought, because it's quite high definition video in a bit of a strange format. So you can stream it to other devices, to your browser or anything, but usually with quite a delay of a couple of seconds. And with my setup, that means the train is around again, full circle. So that wasn't really helpful. So later I searched further, and I found a solution for VLC, so a VLC plugin, but then I could only stream the video in a VLC player, and I wanted to play it in a web-based application where I could control my trains as well. But then I found this one. This is the AirPi Cam Control. Basically, it's an application that you can install on your Raspberry Pi, and instead of streaming videos, it streams pictures, and it refreshes every few milliseconds, so that you cannot really notice that it's a picture, but it's almost fluent. This one has some extra options, such as motion detection and recording images and stuff like that. So if you want to do anything with a camera and a Raspberry Pi, I can highly advise this application. I also wanted to automate switches, because when I was younger, I had automated Lego trains, and the switches were also automated. I could press a button, and the switch would open or close. The new ones, they only have a yellow lever. So I tried to automate them, looked up for some solutions, and I saw some people who basically they drilled a bit of their Lego switch so that it would move smoother. But if you ever plan to do that, don't mention it on a Lego forum, because those people will hate you forever. So I wanted to have a Lego forum safe solution, and we bought these servos, which are basically high power servos powered by an external adapter that basically control the lever. This is, by the way, an enterprise-grade solution. Paper clips, you probably all saw them. These are the 4 most expensive ones in the world, because we spent half a day with 4 colleagues bending them in the right shape, because if they're too long or too short, it won't open or close. So yeah, I had a lot of fun with all the Lego trains and stuff, and then I saw this one. I was like, okay, I need a good excuse for my boss to pay for this one as well. So I told him, okay, if we have a booth at a conference and those trains, yeah, they don't really catch your attention because they're quite small, and it attracts attention. I was like, okay, good idea. So I bought one. And I was, okay, how am I going to automate that? And it's really simple, because this is the same infrared receiver as on the train. So the same software that's running on the train is also running on this Raspberry Pi. Really easy. And you can see here that it's using the same engine as Wally. LEDs, I mean, if you do an IoT project, you need to do something with LEDs. That's basically mandatory. But I thought using LEDs on a Raspberry Pi, that's a bit overkill. I mean, powering LEDs is really simple. So I bought these things, particle photons. They are basically an Arduino, but then with integrated Wi-Fi on it. And the cool thing is that if you buy one, you connect to it with your smartphone, you supply your router credentials, and then it automatically connects to the cloud. And in the cloud, you also have the development environment. So I can program the code, which is Arduino-like code, and then I can say, okay, flash it to one of my particle photons. So it's a really nice environment, and they opened up the cloud environment as well, so you can also connect to it with your Raspberry Pi, for instance. So it's a really nice solution if you want to do a bit more simple stuff. But I quickly noticed that it's way more limited than programming Java on a Raspberry Pi. For instance, in the beginning it didn't work. I couldn't control the LEDs. And then I changed all my code to make it really basic, named my method simply test, because I didn't came up with a better name, and tried it again, and everything was perfect. And then I slowly returned to what I had originally, and I found out that if the method length is too long, the program doesn't run. So later a colleague wrote some code as well, and he had the same issue, and I was like, okay, simply make simple method names, and then it's okay. So it's a nice IDE, but it doesn't warn you up front that it's wrong, so that's a bit of a pity. And for the architecture, Lego bricks. I don't know if you ever bought Lego bricks, so you can buy them in boxes like this. Really annoying, you pay for the box, so you have to put in as much as possible, especially if you're Dutch. So I didn't need these ones, but I mean, I paid for the box, so I simply filled it up as much as possible. So how does it look like? We have the Lego Train Control Center. It's an Angular application, a JavaScript application, and it basically uses the LTCC application on my laptop, which is written in Java, and it connects with REST. This is, of course, the universal REST symbol. My colleagues didn't get it, but luckily you got the joke. From the Lego Train Control Center on my laptop, I connect to the device control application on the Raspberry Pi on my train and for the Ferris wheel. And they use an infrared library for sending infrared signals, and an RFID library, which were already available. So basically, the Java is a wrapper around some libraries that we adjusted, so we didn't have to write the code ourselves. And the same goes for the switch control, which used a Python library. So that was all cool, but then we did a Scala and Akka course, and we were really excited. But I hate building HelloWorld because it doesn't say anything. I mean, of course, a language, you can build HelloWorld with it. And most of the time, after building HelloWorld, you stop. So we needed something more challenging with Scala and Akka, and we decided to rebuild basically our entire application. And the nice thing is that for the communication between the laptop and the different devices, the different Raspberry Pis, we no longer use REST, but we use Akka remote actors, as I will show later. So I only need REST for the Angular front end, and the RFID library also uses a REST endpoint. So how does it look hardware-wise? We have a router. We connect the switch control, the laptop, and the camera, everything simply to the router. In the beginning, I did that through wireless, worked perfectly at home, but then we did it at a conference, and there's way too much Wi-Fi at a conference, so basically it broke down. So after that, we wired almost everything, except, of course, for the trains, because it's a bit silly if you have a network cable behind your train. So the device control is running on my Raspberry Pi. We connect to it through the USB Wi-Fi dongle, and it sends the infrared messages to my Lego train. That's basically it. Probably you're all waiting for the demo already. So we have LEDs, we can do some stuff with it, like just display something, increase the brightness a little bit, but that's annoying. It's warm already, so let's put that back. So I put the LEDs on speed and autopilot based, which means that if I change the speed, or if the autopilot makes the speed change of the trains or the Ferris wheel, then the LEDs will show the speed. So if we start with the Ferris wheel, okay, I didn't put the power on, I guess. That's a disadvantage while playing. The battery boxes, they stop after a couple of hours, so you sometimes have to press the button again. Or stop playing, one of the two. Let's see, did I add them all? So now you can see it's moving at speed 3. I think I forgot this one. Yes. Speed 3 forward. Make it move at speed -2 backward. This, by the way, is the overview camera, so that's the camera which is laying down here. I disabled the camera on the train because the traffic is quite high, and sometimes if you have Wi-Fi issues at a conference, basically it uses the full bandwidth of the router or of the available Wi-Fi, and I cannot control the train anymore. So for safety measures, I disabled the streaming of the train, basically. And so we can make these move. See if I can play a sound. Oh, this one. So basically, I can play any song on it. It's just playing MP3s. So, what you see here at the bottom is the location of the blue train. So if I make it move forward, it now detects the crossing. Oh, a little bit too high here, the track, because I needed to put my power cables underneath it. And if it doesn't drive at a bit higher speed, then it stops. So. Now it should pick up the cow. The car. So basically it detects the position on the track. You notice I drive it a bit slower because if I move it too fast, then it simply won't pick up. It's the same with the OV chip card. If you move too quickly next to the reader, then it won't pick it up. You have more expensive readers and more expensive cards, then it can pick up at a greater distance and at a greater speed, but they are quite a bit more expensive. This is only like $5, and it's nice to play around with. And so manual trains is of course nice, but we also want to automate a little bit. So with this part, I can send it a set of commands, and the commands will be sent to the train or to the Raspberry Pi. The Raspberry Pi will execute them one by one, and after they are done, it will simply stop. So after I've sent the command, I could stop my laptop. It will just continue driving. It's quite nice. So I play it. It will move at speed 3 for 3 seconds, stop for 3 seconds, and then play a song. So it's playing the song. So this is fairly simple still, just sending a list of commands to it. I could also make it a little bit more advanced, so let's clear that one. And say that I want to do location-based commands. And what I'm now doing is that I tell the white train to move at speed -3 if the blue train is at the bicycle. And let's make the ferris wheel also do something. So move with speed 2 if it's at the cow. I just enter a few things. Let's see, let's move the blue train. Oh, I need to push it a little bit. So now it's at the cow, Ferris wheel is moving. Car, I don't know what, nothing happens for the car. Bicycle, train's going backwards. And I could even make it in a way that the blue train reacts on itself, so that if the blue train reaches the cow, that it would reverse or something like that. Completely customizable. Let's stop that for a second. And I have the overview camera and big screen as well. And so this is basically what we built with Scala and Akka in a fairly simple way. So let's see a bit about how we did that. Any of you already using Akka? Okay, cool. Few hands, few hands. So Akka is fairly simple to start with. You simply define a class which extends actor, and you define a receive method, and in this case, for everything that I receive, I simply print it. It's like HelloWorld. Then in another class, I define an actor system, give it a name, and I ask for a reference of the worker actor, so that's this worker actor. And then by using the exclamation mark, I can send messages to the worker actor. So this will send hello conference to the worker, which is case X, of course, and then it will print out hello conference. That's basically the basics of actors. Of course, if you do it nicely, you would probably not send strings, but use a bit nicer way. This is a simple example. The nice thing is that, so what we saw previously, we could use within one JVM. Within one application, we can connect with the different actors in that application. If we have multiple JVMs, in my case, on my laptop and on the Raspberry Pi, I need to send calls over the network. And to make a call, it's quite easy. I simply define a reference again to the actor by supplying some extra information, such as IP address and port number. And then I can use the same methods again. So I can again simply use this code to send messages to it. So that works really transparent. If you do that normally with, for instance, REST, and you have one application and you extract a part out of it, if you have a monolith and you want to create microservices, for instance, then you have to define REST endpoints, and you have to change your calls so that it uses REST endpoints. With Akka, you only basically have to define where the actor is living. And you can do a large part of this in the configuration as well. So I put it within the code, which is not so nice, but it's easier to show. So it's basically abstracting away where actors are living, if that's within your JVM or in other JVMs. And we only need a little bit of extra configuration for it, which is basically a hostname, port, and some stuff which you copy-paste from the internet. So I really liked the remote actor system. Before we built it with REST calls within Spring, which also worked, but I like this model a lot better. You don't have to spend a lot of time writing boilerplate codes, which basically REST endpoints are boilerplate code. They're just there because some technical requirements, not because you need the functionality. So what are the advantages of remote actors? No converting anymore. It's done explicitly underwater. It feels more natural programming-wise. It has some extra features, in this case for Akka. HTTP, of course, also has some advantages. It's independent of technology. I cannot send an Akka actor message from Java to .NET, for instance. There is a .NET implementation for Akka, but it uses a different serialization mechanism. So you cannot communicate across applications or across different platforms, basically. With HTTP, of course, you can connect from Python to your .NET application or to your Java application. That's no problem. So it's more loosely coupled. And it's also easier with HTTP to simply say, okay, maybe the server will offer me like 3 fields, but I'm only using 2 of them. And if they add an extra field, I won't use it. So it's a bit more loosely coupled in that way. So I liked Akka and the remote actor system. But I needed a way to convince people to use it, basically, because I don't have blue eyes, so nobody trusts me on my eyes. So I tried to find another solution. And I tried Gatling for performance testing. Any one of you used Gatling? If you haven't used it and you're doing something with performance test, I can highly recommend it. It works really nice. So I define a scenario. It extends simulation. My scenario, I repeat it 100 times, so basically it's looping 100 times. And what it does, it is simply doing a GET request to my ping message, and it checks if the status which comes back is to 100, and then after every request, it pauses for 100 milliseconds. In the setup, I create 1,000 users over 10 seconds, so 0 users after 0 seconds, 1,000 users after 10 seconds. And those 1,000 users will execute this loop 100 times, so you get 1,000 times 100 iterations, basically. And that's everything you need to do to performance test. In my case, I wanted to know what the difference was of the performance of Akka HTTP compared to remote actors. So the first part, it's the same. This is Gatling firing request to a JVM with an Akka HTTP endpoint, same here. The difference is at the end. So here I fire an HTTP request to another Akka HTTP endpoint, and here I have an Akka remote actor endpoint. So I compare those two, basically. For the results, these are the mean response times in milliseconds. So Akka HTTP is clearly a lot longer for the response times than remote actors, especially if the number of users is increasing. For the max response times, it's basically the same. So you would say it's a clear winner, right? But there is also something like Springboot, which is more commonly used than... luckily, you got the joke. Which is more commonly used than Akka HTTP. So I wanted to compare remote actors with something which is what we normally use in our projects, which is Spring, basically. And if we then look at the mean response times, it's a little bit annoying because Springboot is quicker. So it's like, okay, now I can falsify my results or something like that. But luckily, when I looked at the max response times, I noticed something different. And that's that the remote actor system, it scaled much better. The max response times were a lot more stable than for Springboot. And I have to mention one thing with it. I didn't do any performance tweaks. Of course, if you go do performance tweaking your application, you could get other results. The only thing I changed is that Spring, it uses a REST template to connect to a HTTP service. And the REST template is using a quite bad connection factory, which broke after a couple of hundred users. So I used a different connection factory from Apache. So that's the only thing I changed. I didn't do any tweaking on the Akka side. So for me, I mean, it's not that you always have to use Akka or always have to use REST. I think it's figuring out what's the best solution for your problem. If you have an application with lots of concurrent users with a high load, then this can be a good solution. And what we found out, also a graduation student did more or less the same test with a different setup. And he found out that Akka could handle 5 times the load that a Spring application could handle in our simple setup. So that means the difference between buying 1 or 5 servers or renting them. So that's quite a good business case. And so if you have high volume loads, then I can really recommend Akka. If you have an application which is only moderately used, then probably REST is a good solution as well. Challenges, this was not my house, but I burned down an infrared transmitter because on the internet I found an instruction on how to connect it to my Raspberry Pi, connected it, went downstairs, went upstairs, and it smelled a bit funny. That was the end of it. I broke a Raspberry Pi, the new models, the A+ models. I bought 3 of them, and actually I broke 3 of them because I inserted the USB Wi-Fi dongle, didn't work. Tried the second one, didn't work. The third one, I simply connected without inserting the Wi-Fi dongle, worked perfectly, inserted the Wi-Fi dongle, and it was broken. So then I looked into the USB connector, and normally if you have a USB connector, there are pins basically holding your USB device steady. With the Raspberry Pi Zero, they use a bit of a cheaper solution, and the pins are a little bit high, so if you push something in, the pins will bend backwards, and that's basically the end of your Raspberry Pi. If you ever buy Raspberry Pi A+ models, use a screwdriver to bend the pins first and then insert the USB device. That was the solution for it. But those things, it all takes quite some time. I mean, you think an evening, okay, I had everything working on bigger Raspberry Pis. I thought, how difficult can it be to install the same stuff on a smaller Raspberry Pi? But it ended up costing me a couple of days because I had broken hardware and some other issues. So the main challenge is time. And I often get the question, how much time did you spend on this? And actually, most of the time was in evenings and weekends, and I didn't record how much time it was. And even if I knew, I wouldn't tell you, because my wife would probably be upset of me playing too much. So if you want to do it yourself, I got the question a couple of times. We didn't want to open source the Scala and Akka code because it's a bit messy. But I made a new setup based on Springboot, which is, I think, better to understand for most people. And you can simply install it on, for instance, a Raspberry Pi Zero, the new models, which are even smaller than the stuff that I use. And if you use the newest Raspberry Pi Zero, it also has integrated Wi-Fi, so you don't even need a USB Wi-Fi dongle. And with this code, basically the LCC install script will install all the dependencies that you need. It will configure Linux in a way that everything works, and the LCC application basically controls it. So to have a look at that. So the LCC application is really simple. It's a Springboot application, which has a controller. So basically, if I go to the URL /intensity and I provide it with a value, then it will send the value to my device manager. Okay, it doesn't work directly. Send intensity, and that will basically in the end call a C script which is running on my Raspberry Pi. So the C script is sending the infrared signals in the end, underwater using Lyric, the Linux infrared protocol. So this is basically all that you need to get running. So this is also easy to extend if you want to do things with it. And what I built as an example, to not build something with trains or something, I built a car. Different engine than, for instance, Wall-E or the trains, but main controls is still the same. This is also an engine, so it has one steering engine and one power engine. And the really small thing over here, that's the Raspberry Pi, which you can buy for like 10, 15 bucks. There is a camera somewhere hidden here, and I can simply control it by sending some REST calls to it. So let's see if I can send some. So I made a really simple application so that I could send a few commands. Speed, I limited it to 3. I can make it go as fast as 7, but it's quite hard to control it then. Of course, it doesn't work. Let's see. Does it work? Oh, the infrared transmitter is bent, so then it can't reach the infrared receiver. Let's see if I can make it move so that you can see it up here. Simply move my camera, that's probably easier. So basically this way you can control any Lego that you have, which is using power functions. That's the name of the electronics from Lego. I forgot to show one thing from the Akka part. So the same stuff as I shown you before, we implemented it with Akka actors. And if you look at how Akka works, you also define sort of REST endpoints in this way. So if I go to the speed, make it a bit bigger, speed endpoint, I can supply it with the speed, which is -7 until 7. And then I will call the train service, and I will call it, or will send it the message, and the message is called set speed. The ID is the ID of the train, and the speed, of course, is the speed of the train. And I expect to get a result back of the type set speed result. So if I look at the train service, I will get the message set speed, and then it will call the set speed method, which is this one. It will call my Akka actor, and that's then the Akka actor running on my Raspberry Pi. And I send it the speed. So I either send it backward, a backward message, a brake message, or a forward message. And if the lights are enabled, I also send the speed to the lights so that the lights will display the current speed of my Lego. So if we look at the train service, which is running on the Raspberry Pi of my train, I can receive a few messages, such as brake, forward, and backward. And based on those messages, I will send the command to a CGI bin script, which is a URL. In the Spring application, I refactored it, so it's a C script, but here it's still a CGI bin script running on a web server. So that's basically how Akka actors work. So it takes a little bit of time to get used to it. It's a bit of a different programming model than REST, but it's fairly simple, and you see that with only a few lines, I can communicate between different devices. So for conclusion, except for having a lot of fun and having the ability to visit lots of cool places, I didn't put a picture of Amsterdam in here because I worked here for 3 years, so it's actually quite normal for me, but I presented the session in the United States, everywhere around Europe, so that was quite cool. So we had a lot of fun, and it attracted a lot of attention as well, so we put it in our booth, and everybody, of course, is interested in Lego. But it also had a useful part. We had a lot of experience with doing Java development, Scala development on a Raspberry Pi, and we found out that the Raspberry Pi is quite suitable for it. The ones we have are quite limited for memory, so we reached almost the limits of it, but the new ones have way more memory, so it's even easier to run on it. And because we did the Scala and Akka stuff on our Raspberry Pis, after we followed a course on it, we could use that experience later when we built enterprise-grade Scala and Akka applications for our customers. So we didn't only have fun, we learned a lot, and we learned a lot of things that we could later use in other projects to get an advantage there. Best part, I don't know if you all already saw the video, but I like it, so I play it again.
Beer and chips, please.
And so the speaker will say, beer and chips, please.
Beer and chips, please.
There was one part that was hard to automate, but luckily my wife would help me out with that.
Beer and chips.
So we reached the end. Any questions? Thank you. Any questions? Yeah.
There is one obvious question, of course, when we play with Lego, is did you get hurt while doing all this? Like stepped on it or something?
Yes, exactly. I stepped on it, so that hurts your toes. Sometimes it broke my ego when it didn't work, but for the rest I didn't really get hurt, luckily. Original question, by the way, never had that one.
You said that we can't use different technologies with the remote actors mechanism. Is there a way to some kind of do that?
A good question. So with remote actors, you cannot send the messages from, for instance, a Java application to a .NET application. The way to fix that is to do a REST call. So in Akka, you can create REST endpoints, and you can call those REST endpoints, but then you miss the benefits of remote actors, because remote actors, I didn't tell that before, but they don't use HTTP. They use Akka over TCP, which is a lower level protocol, so it, yeah, most cases will perform better as well. And you miss that benefit, but it's still possible with REST endpoints. You mean operating with Scala and Java? Maybe if you manage to use the same serializer, but I'm not sure. I think you quickly run into issues there. Yes?
Does the code change when you use HTTP instead of Akka remote?
A good
still
question.
Sending the same messages?
Yeah. So does the code change when you change it from remote actors to using REST? Yes, because then you need to implement REST endpoints. So you... Good question. Does it change from the client side? No, you have to send REST messages with JSON or something like that. Of course, you probably could use a library that translates it underwater. Maybe there is already a library available, but I'm not aware of that. But normally, the call changes at the client side as well. Yeah. Okay, thank you. Good questions.